PMS, pregnancy, menopause. Each stage of womanhood has its unique challenges. That's why Highlands Naturals' new women's multivitamins are formulated with essential daily nutrients, plus targeted support for your life stage. Facing PMS? There's a Highlands Multi for that. Navigating pregnancy and morning sickness? That too. In the throes of menopause, our formula is here to support you through hot flashes and skin changes. Gone are the days of juggling multiple supplements or guessing what you might need. With Highlands Naturals, it's one multivitamin with daily essential nutrients and science-backed ingredients to support you. An all-in-one wellness solution to lighten the load for women? Highlands Naturals is here for it. Find your multi at Amazon or Highlands.com. That's HYLANDS.com. Highlands Naturals. We're here for it.
Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024. And no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/auto loans. That's scfederal.org/auto loans. Certain restrictions apply. Existing South Carolina Federal credit loans are excluded.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thank you for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and joining me, as always, is the great Professor Fred Watson, or Astronomer-at-Large. Hello, Fred.
Hello, Andrew. How are you doing? Are you well?
I am really well, believe it or not.
That's good.
Yeah, much recovered. Just took a bit longer than it would for most people because I'm just a sicko. But we've had a bit of a COVID development in Dubbo in the last day or so. We were notified late last night that a traveller had stopped in Dubbo, travelling from Melbourne to the Sunshine Coast in Queensland, and stayed the night in Dubbo and visited several places in town. And, of course, they were later diagnosed as COVID positive. So now the whole city's on ready alert. Everybody's being urged to go and get tested if they've got symptoms and lock down or isolate. We haven't been locked down yet, but we're waiting to see where this goes. Hopefully nowhere. But we're on tenterhooks at the moment. So fingers crossed this doesn't turn into anything. But yeah, it's a bit of a scare. But on the plus side, Fred, I think it'll wake a few people up, because I think we've been very complacent in this part of the world, in light of the fact that we haven't had a case in this region for a very long time, and people are just sort of sitting back and relaxing and drinking their pina coladas and thinking that what's the rest of the world worried about? Well, it's
now here
it is.
Yeah.
So fingers crossed. Now you've had an interesting time, because you went to Siding Spring Observatory and got snowed in.
Indeed, that's right. So we were officially snowed in last night on the mountaintop, Siding Spring Observatory, about 150 kilometres from where you are, and probably 700 metres higher up, I think. And you probably had a lot of rain last night.
Yep.
We got blizzards pretty well. We essentially were stuck on the mountaintop. It was fine because the plan was to be stuck on the mountaintop. We stayed at the Siding Spring Lodge, operated by the Australian National University. But this morning, when you and I were planning to have our Space Nuts podcast recording, we were advised that the road was clear, but it might not be clear for very long. So we hot-footed it out of Siding Spring and made the 6-hour journey down to Sydney, which is where I am now. And it rained all the way, Andrew, every bit of the way.
Yeah. We've had torrential rain, some of it sideways, because we've had big, strong northerly winds blowing the rain in. The radio station leaked this morning because it was hitting the side of the building. So we found out where all the holes are, and that's the same place the mice have been getting in.
Oh, yeah.
It's been a pretty horrific couple of days, and we've had temperatures. I think we managed to get to 5 or 6 degrees today, and not much better yesterday. And yeah, there's been snow in places you just don't ever see it. I mean, Coonabarabran up around the Siding Spring Observatory doesn't get it that often.
No, that's right. So it was 0 this morning at Siding Spring, 32 degrees Fahrenheit. And it looked, to my mind, it looked as though it was set to be snowy for a little while. And the last time I remember it doing this was, believe it or not, in 1984, when we were snowed in for a week, I think, if I remember rightly. And there were snow men and snow women appeared all over the mountaintop because that was the only thing to do.
Snow persons, as we called them when I worked for the ABC. Snow persons, right. Yes.
That's what they were.
Yeah,
anyway.
well, as we speak, Fred, we're getting another torrential downpour. It is bucketing here at the moment. So, yeah, we've had well over 46 millimetres so far, but it doesn't sound like it wants to finish yet. And it was supposed to have gone, a few hours ago, but it's still around. Anyway, we're going to get down to business because we've got a lot to talk about. On today's edition, episode 250, whatever it is, 256, I think, we're going to talk about MAVIS. Now, you're probably wondering what MAVIS is. Well, MAVIS is a very popular Australian name, but it's also the name of a planned observatory that is going to be more powerful than Hubble, and it's an Australian creation. We're going to look at a dying supermassive black hole. It's not going to go out with a whimper, I don't think. We had a question from Sean in Charleston, coincidentally, because you'd already chosen to talk about this topic. He was asking questions about the Pentagon's release of pictures and videos of UFOs, which they've sighted around San Diego. So he wanted to know what we thought about that. Well, I have no clue, but we will talk about it. And we've got questions about radio galaxies and the North and South Pole and the Earth's rotation and the melting of the ice caps, what effect it might have. So we'll tackle all of that today. Okay, let's start. Fred, who is Mavis and why is she in the news?
Yeah, she's not... she's not a person. Normally Mavis is a who, but this is a what. And it's actually an instrument which is being built in Australia for the European Southern Observatory's Very Large Telescope, which is in Chile. And basically the instrument is going to, as you said, it's going to outperform the Hubble telescope on one of the 4 8.2 metre telescopes of the European Southern Observatory's Very Large Telescope. That's its name, collective name for these 4 telescopes and a few other small ones besides. In fact, MAVIS is destined for a telescope which is officially known as UT4, but all those 4 8.2 metre telescopes of the European Southern Observatory have got names from Chilean indigenous culture, and UT4 is Yapun. And I can't remember which one that is. I think it is... It may be Sirius. I think it's Sirius, the brightest star in our tradition. In Chilean, Yapun is... Probably. The other ones are named after things like the Southern Cross and other constellations. Anyway, enough of that, because that's not about MAVIS. MAVIS is actually an acronym. You might have guessed that, Andrew. And it stands for...
Shocker.
Shock horror. It's first, the M is actually an acronym itself. The M is short for MCAO. And MCAO stands for Multi-Conjugate Adaptive Optics. So what that means is some very fancy technology that takes the twinkle out of stars, because the twinkle is a blurring effect. Astronomers hate it. And without the twinkle, you would always have performance equal to the Hubble telescope. So the twinkle remover, MCAO, is the M of MAVIS. The rest is Assisted Visible Imager and Spectrograph. There you are, MCAO Assisted Visible Imager and Spectrograph. And so what it does is what its name implies. It will allow you to form images of celestial objects with incredible clarity, because you're essentially eliminating the atmosphere, even though you're in a telescope on Earth. It's about 12,000 feet, I think, rather more than 3,500 meters, I think, is the height of the VLT, thereabouts. and that gets you some of the way, but the adaptive optics system is what really eliminates the blurring effect of the atmosphere, and so it will form images that rival Hubble, and in fact, essentially, it's expected to be 3 times clearer than Hubble. Sometimes these things take a while to get to, but the other side of it, the spectrograph, that's the really important bit, because a spectrograph is that universal tool that astronomers use to probe what stars are made of, to probe what's going on in galaxies, to probe whether stars have planets around them. All of these things come out of observations with a spectrograph in which the light is broken up into its rainbow colours, and we analyse that barcode of information that is superimposed on the rainbow spectrum. So it's fantastic stuff. It's a number of universities that are involved. The leader, actually, of the project, I think he's certainly one of the senior members, a chap called Richard McDermott, who I know well. He's at Macquarie University here in Sydney. Richard and I have in common that we were both educated in the same Scottish university. The University of St Andrews formed in 1413, and I was there a couple of years later, Andrew. That's what it feels like, anyway.
You beat me to it.
Yeah.
I'm sure it does. Well, do we know when this will be online?
I don't know, but it's what's happened is the Macquarie and other institutions, including the University of Sydney, and I think there's an Italian component, as well as the Australian National University. They have done a sort of feasibility study, which has been accepted by the gurus at the European Southern Observatory, and they're now kicking off to build it. The expectation is about 7 years to build. And these things, they take a long time, Andrew. They're not quick to build. One of the things that I was doing up at Siding Spring Observatory was basically sorting out a lot of stuff in the laboratories that I used to use when I built instruments, and I took decades to do it. So that was in the days when I used to build fibre optic instruments for astronomy. So it's 7 years is a sort of typical time for a major facility instrument like this. But what a thing to look forward to. As Richard said, he said that the instrument will permit scientists to push into a new frontier of the furthest and faintest things we can see.
Wonderful. Wonderful. And possibly answer some of the questions that have been posed for many, many years. And yeah, can't wait. But 7 years. All right. Well, I think we can handle that. It's better than trying to wait for a message from interstellar space, isn't it?
Well, that's right. A telegram or something like that. Yes.
Moving. Yeah, that's right. Or carry a pigeon. A space pigeon, of course. Now, moving along, a supermassive black hole is dying. How does a supermassive black hole die, and will it go out quietly, we hope?
No. So this is...
I kind of figured.
Yeah. We have in space what we call AGNs. An AGN is an active galactic nucleus. In other words, it's something that is detected usually with radio telescopes, and it's telling you that the supermassive black hole at the center of this galaxy is voraciously consuming its surroundings. So there's this accretion disk of material spinning around it, which is being refocused. Some of it goes inside the black hole. Some is refocused by the magnetic fields of the black hole to form jets, which point right angles to the accretion disk. We've discussed that many times. But the active ones are very strong in radio emissions. And AGNs have been observed, active galactic nuclei have been observed for many decades. They are the stock in trade of the radio astronomy fraternity. They were high on the list of targets when I was a young astronomer. And in fact, the most extreme form of active galactic nucleus is something called a quasar, which is an AGN that's kind of going gangbusters. However, what's happened here is that we've seen an active galactic nucleus that has shut down. It has actually already shut down. In other words, the hyper strong activity of the black hole has switched off, probably because it's run out of stars and gas and things to gobble up. The area around the black hole at the center of of its galaxy is now devoid of the gas that it needs to keep it active. So the active galactic nucleus has switched off, but we can still see it because there is something that I've always been fond of these things. It's called a light echo. So what you're seeing is basically the ends of the jet of material that was squirted out of the black hole. You can't see the jet anymore, but you can see the sort of gigantic bubbles of gas at the end of the jet, which are still being illuminated by the light from the black hole itself, which is from the active galactic nucleus itself, which has taken a dogleg path to get to us. It's gone out from the black hole, it's illuminated this jet that's been squirted out above and below the black hole, and then that's reflected it to us. And what it's done is put a 3,000-year delay in the time that the light has taken to get from this galaxy. And that's exactly what we call a light echo. We see it in many phenomena. Sometimes a supernova will shine on a dust cloud nearby, and the dust cloud lights up years and sometimes decades after the supernova has exploded. But this is a very nice example of that happening in the case of an active galactic nucleus.
Yeah, I think we've touched on similar things before where we talked about an event that happened, a long time ago, but because of gravitational lensing, you could watch it more than once.
Yes, or reflection.
I suppose this is similar in that there's been a delayed effect.
Yes, that's exactly right. It's the delay that makes it a light echo.
All right. So tell me, what is the future of this black hole? What's ultimately going to happen to it?
Well, the black hole will stay contented at the centre of this galaxy, whose name, by the way, is ARP 187. Halton Arp was an astronomer. I met him once years and years ago, who catalogued active galactic nuclei and galaxies, in fact, optical galaxies. But the black hole will continue, but it's run out of steam in the sense that it's used up its fuel. Now, we think that is a process that is, it basically shuts down an active galactic nucleus, because once the fuel's gone in the vicinity of the black hole, there's nothing for it to consume, and there's nothing, it's actually the disk of spinning material going around the black hole that causes the energy to come out. If that's not there, then you don't see it. And you've got what might be called a quiescent black hole, one that is not actually radiating lots of energy.
So it'll just sit there like a blob and do nothing for a long, long time.
That's about the size of it, Andrew.
Yeah, that sounds like me. Okay.
No comment there. No comment whatsoever.
No, I'm just paraphrasing my wife. You're listening to the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Time for a word from our sponsor, NordVPN. Do you want to protect your data and enjoy the internet without restrictions? Of course you do. And the way I've been doing it is with NordVPN. NordVPN is a VPN service that helps people access the web freely. It gives users complete anonymity online, protecting them from snoopers and hackers. You can use it on any device, including mobile phones, tablets, laptops, or desktop computers. With NordVPN, you can bypass censorship filters and get access to websites that are blocked in certain regions of the world. By using NordVPN, you'll be able to stream videos with no buffering while abroad or at home. Enjoy unlimited bandwidth for all your devices so you don't have to worry about running out of data again. Protect yourself from cyber attacks by encrypting sensitive information like banking passwords, credit card numbers, all those sorts of things, which means nobody will be able to see what's inside your messages if they're intercepted by a hacker. Plus, they're rated #1 for speed in a recent test of VPN services. It's a no-brainer. And our special offer makes getting started easy. Get started with our special offer today, save some money, support Space Nuts, and experience true internet freedom for yourself. Go to nordvpn.com/spacenuts or use the coupon code SpaceNuts to get a 2-year plan plus 1 additional month with a huge discount. That URL again, nordvpn.com/spacenuts or the coupon code SpaceNuts. And I'll put the URL details in our show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Well, I do have some very exciting news, and that is in regard to the Space Nuts shop. Now, if you go to our website, spacenutspodcast.com, and click on the shop link, you will find our shop. And we've told you about things before, the T-shirts, the polo shirts, the stickers, the mugs, the dad caps, all of that sort of thing. We have introduced some new products. We have socks. We have pom-pom beanies. I'm not kidding. We've got the Eco Tote Bag. Wait a minute. I'm going to turn the page. Oh, laptop sleeves. We've got some of those. We've got bucket hats. We have got, well, obviously there's books in there. There's a brand new one in there too called The Hitler Paradox. Interesting. We have got just about everything you could name. And if I go to the final page, you've got to go right to the end, you will find, I'm not kidding, the unisex hoodie, but we've also got a bomber jacket. Yes, we have a bomber jacket with the Space Nuts logo on it. So if you would like to grab something like that for yourself or a dear friend or relative, go to spacenutspodcast.com, click on the shop link and have a look through the vast array of product. Hugh has been working his proverbial tail off to bring us new stock and new ideas and new concepts. I think you can even get a pair of flip-flops. I use the American terminology for you in New Zealand, jandals, and for the Australians, thongs, and you wear them on your feet. Just thought I'd better remind you of that. So check it all out at the Space Nuts Podcast website. Okay, Fred, I know you're getting yourself some flip-flops, but I'm going to play a question that's come in for us. This comes from Sean in Charleston. He actually asks us 2 questions, but it's the second question that we're going to be discussing about these photographs of UFOs. So this is from Sean.
Hello, Andrew and Professor Watson. This is Sean from Charleston, South Carolina, U.S., and I have 2 questions. My first question is, with the outer universe being 13 billion light years away and change that you can see, and light took 13 billion years to get here, does that mean that in reality the outer edge is now 26 billion light years away? That's my first one. Second one is for the both of you, actually, what your opinion is with all this U.S. Navy UFO things flying around off of San Diego, flying at high speeds, making 500 G right-hand turns. What your colleagues' opinion is it all bunk, or do you think there may be something of it, not as little green men, but as the technology of being able to do this? Thank you. You have a great show. I can't wait to hear it every time. So you guys have a good one. Thanks again.
Thank you, Sean. He asked some interesting questions. I think the one about the 13 billion light years we've actually tackled that before, and it doesn't double. You might want to just finish that off for me, Fred, because that's as much as I can say.
No. So Sean's question is a good one. And he's on the right lines, but it's actually a little bit more than what he's suggesting. So if you think about this, okay, we see the Big Bang. We can see the flash of the Big Bang in the cosmic microwave background radiation, and that is at a look-back time of 13.8 billion years. But it's not at a distance of 13.8 billion light years, because the universe is expanded by a huge amount in that time. So since the expansion of the universe has been going on ever since that light left, we can calculate that actually the distance to that horizon, the cosmic microwave background radiation, is more like, and I can't remember the exact number, it's more like 40 billion light years. But we're seeing it as it was 13.8 billion years ago. So the distance, it's where the distance and the time really get separated. So one is a look-back time.
Right.
And the other is, we actually give it a name. We call it the proper distance, rather than something called a co-moving distance. There's some technicalities there. But the 40 billion light years accounts for the expansion of the universe that's taken place in that 13.8 billion years. Okay, that's got rid of that one. Okay. So, what do you think? What do you think of the UFOs? Andrew?
Yeah, what I haven't really delved into the story myself. I've heard it in the news a few times, but I haven't really read much about it. But I think I'll stand by my previous statements in regard to this. I certainly believe that there is technology in the world that is beyond anything we've been privy to. And I do believe there are capabilities that we are achieving beyond the technology that we know of today. And so I think this is a human creation, and I think these possibly military type applications that are being tested. And I don't believe they're manned, because I don't think anyone could survive a 500G 90-degree turn. But I do think that there is probably some technology in play here that we are not privy to. That's my theory. Until I'm proven wrong, I'll stand by that.
Okay, it's a good one. So the reason I was going to raise this topic today is because there's a really interesting article on The Conversation, UFOs, How to Calculate the Odds That an Alien Spaceship Has Been Spotted. And it's by a scientist at the University of Oxford. And he has applied something that in astronomy we use a lot. It's really almost the cornerstone of some of the deductions that we make about the universe. And it's called Bayesian statistics. Bayesian statistics actually is kind of slightly different from normal statistics, because you start off with something called a prior, which is an assumption that something might be the case. So I don't want to go into the details, obviously, because it's very mathematical. And between you and me, Andrew, I'm not sure that I understand it either. But anyway, this scientist uses Bayesian statistics to come up with more or less what I've been thinking as well, which is that yes, there is clearly something going on, and you've put your finger on it, that it could be as yet unadvertised technology. There is something going on, and the idea of a UFO, an unidentified flying object, we all associate that with the idea of alien technology, extraterrestrial technology. But actually, the expression itself doesn't demand that. An unidentified flying object is just that, an unidentified flying object. And when you apply this sort of statistical analysis, you get to the conclusion that it could be one of many, many things. In fact, the author of this article I think he was being a little bit tongue in cheek, but he said, these things in the sky could equally well be fairies, intrusions from the fifth dimension, swamp gas, foreign drones, sapient octopuses or anything else. And, you know, that's equally probable as it being alien visitation. There are a few other things, and there are some things that you would have thought might have been ruled out, but that might behave the way that that some of these objects have done. One, I spoke to one of the pundits a few days ago, somebody who's kind of close to the action on Space Nuts, and as I won't give his name, but I thought this was a very good guess at what might be going on here. Weather balloons. Weather balloons get everywhere, and because they can move with the jet stream, they can move extremely quickly. And of course, a 500G turn is absolutely no problem to a weather balloon. And that's, but my point is not so much copying what Stuart mentioned on our sister podcast, but it's to say that these things could be anything, and it's. You know, the Bayesian analysis that this scientist at Oxford University went through came out with a 1 in 1 billion probability that this was a result of extraterrestrial technology. And part of that comes about because, like me and many other scientists, we are very uncomfortable with the idea of there being much other than rudimentary, perhaps, you know, single-celled organisms out there in space, just because of this huge jump that you need in thermodynamics to get from a single-celled organism to a multi-celled organism. Now, of course, because there are 10 to the power 23 planets, at least in the universe, you can never rule it out. But the thing that's, you know, that one of the other things that pushes down the statistics as far as alien visitations is concerned is just the enormous distances between stars and galaxies, and this all plays also into the Drake equation, and you know, when you put the modern numbers into the Drake equation, you get very, very low probabilities of there being species like ourselves within our own galaxy, if not within a much broader swathe of the universe. So I think, like you, Andrew, that eventually we'll find out what these things are, but they are not necessarily anything to do with extraterrestrial civilizations.
No, most likely not. And you know, there's nothing to suggest that it's one single thing. It could be a multitude of phenomena. It could just be a trick of the light. It could be swamp gas, as they suggested. It could be technology. It could be any number of things. It could be ball lightning on occasion. You just don't know. Yeah. And until we've got conclusive evidence, then we just keep looking.
One of the things that this author of the Conversation article, and I might tell you his name, he's Anders Sandberg, and he's at Oxford Martin School in the University of Oxford. One of the things that a comment that he makes is that science did not believe in meteorites until trustworthy multiple witnesses brought in rocks found to be of unknown minerals, and our understanding of the solar system allowed for asteroids. So it's interesting to look at history as well when you think about these things, as well as Bayesian statistics. And maybe, you know, in a few years' time, we'll all be chuckling at the way we were deluded into thinking this was something, you know, extraterrestrial.
Yeah, very likely. But isn't it so human of us to try and attach the unknown to something that we can understand or want to believe? And you know, that's been documented throughout human history. So you know, we think we're so advanced and so very clever today, but I think there are times where we demonstrate we are still, you know, quite naive, I think would be the nicest way to put it.
But
this is the Space Nuts podcast.
I was just going to say,
this is the Space Nuts podcast. You're with Andrew Dunkley, and go on. We've got a time delay, which is causing us some problems. So I don't know why that is. We call it the internet, I think.
I was just going to say, Andrew, it's great fun. It's great fun as well for us to speculate on what it might be, as long as you don't take it too seriously.
Indeed. For certain. Okay, we're going to take a little break. This is the Space Nuts podcast. Andrew Dunkley here with the good Professor Fred Watson.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Roger, you're loud and clear here also.
Space Nuts.
Just want to shout out to our patrons, the people who put their money where our podcast is. We thank you deeply with as much gratitude as we can foster for the people who put a couple of dollars a month into the podcast because they believe in us. We really do think you're wonderful. So thank you. If you'd like to become a patron, go to our website and just click on the supporter link and you can find out how to do it. And there are several different ways and there are all sorts of different levels. So you don't have to spend a fortune. You don't have to cash in the Maserati. You can, unless it's a tiny little one that you buy in a box from a toy store. But it's not expensive to do and it's totally optional. But if you go to spacenutspodcast.com, click on the supporter button, you can find out how to support us. And of course, as I mentioned earlier, the Space Nuts shop, that helps us as well. And you get something for your dough, a sticker or something along those lines. But anyway, thanks for your support. Appreciate it. Those who choose Patreon or Supercast, it's a personal choice, but you're all wonderful, wonderful people. Now, Fred, question time. I know we ran a question earlier, but only because it related to something that you wanted to talk about. Let's go through a couple of audio questions now. And this one comes from Queensland. And if I may just take a little moment to self-indulge, Paul, 50-6. 50-6. I will say it again. 50-6. That was the score between New South Wales and Queensland in this week's State of Origin Game 1. I will eat my words when we lose the series 2-1, but for now, I'm going to gloat. This is Paul.
G'day, Professor Fred and Andrew. This is Paul from Queensland, Australia. Congratulations on being one of the top 10 astronomy podcasts in the world. It's an awesome achievement, but no great surprise for us fans. Professor Fred, my question is about radio galaxies. What exactly are they, and how are they different to ordinary galaxies? My second question is related to the first, and it's this. Would the Milky Way be considered a radio galaxy if it were, say, viewed from the Andromeda Galaxy? Or is it just not emitting enough radio waves from, the central black hole? I think it's got something to do with that, but I'm just not sure. Anyway, hope you can set things straight for me. And thanks again for your amazing work, you two, and to Hugh for putting everything together. Cheers.
Okay. Thank you, Paul, and commiserations. And Hugh doesn't do anything. Actually, he does. He works very hard behind the scenes. Okay, Paul's asking about radio galaxies. What are they, and are we in one?
Yeah, so it sort of follows on from what we were talking about earlier with the active galactic nuclei. And radio galaxies were detected in the early days of radio astronomy, not long after the Second World War. And that was the name that was given to them, radio galaxies. And then people realized that some galaxies were much stronger in radio emission than others, and that's how the whole idea of active galactic nuclei came about. What we were just talking about of black holes consuming their surroundings, the surrounding gas and stars at a highly voracious rate, and basically re-emitting that some of the debris through the jets, the polar jets of the galaxy. So that is the that's the more extreme end of the radio galaxy spectrum, if I can put it that way. And as I mentioned, the further, even more extreme end is what we call quasars. They were originally called quasi-stellar radio sources, and that kind of hints at the confusion when they were discovered, because quasi-stellar looks like a star, but they're actually in radio and they're point sources. We now understand them as being extremely active galactic nuclei. They're caused by black holes that are really devouring what is around them. So to the second part of the question, which I don't think we've been asked before, Andrew, it's a really good question. Is our Milky Way galaxy an active galactic? Sorry, is it a radio galaxy? It is, in the sense that the nucleus is indeed emitting radio waves, and it was one of the first radio sources in the sky that was discovered, the galactic center, after the sun. The sun was the first thing that radio astronomers found, actually before the Second World War. But the second thing, I'm pretty sure I'm right in saying this, was the center of our galaxy. A radio source that we now call Sagittarius A star. Sagittarius A is in fact, it's the first source in the constellation of Sagittarius, hence the name. And the star came about to distinguish it from another object. It's also strong in X-rays, and often, well, that's probably where the A came from as well, because of the X-ray radiation that comes out of it. So in that sense, our galaxy is a radio galaxy, but it's not a strong one, because we definitely do not have an active galactic nucleus in the center of our galaxy. And that's just as well, because it would be really radiating, electromagnetic waves, X-rays, radio waves, infrared as well, much more violently than it is now. However, and this, I hadn't thought of this, Andrew, when we talked about the active galactic nucleus a few minutes ago, but we know from observations of gas clouds above and below, I think it's particularly below the black hole in the center of our own galaxy, Sagittarius A star, we can see fluorescence in those gas clouds that suggest that, and I can't remember how long ago it was, I think it was only a matter of a few, maybe 70,000 years ago, that sticks in my mind, that our galaxy had a bit of an outburst. Something got gobbled up by the object in the center, and there was a burst of radiation, which we still see in the illumination, the fluorescence of these gas clouds. So it probably would have been quite radio loud at that time, and maybe, and I'm just guessing here, but maybe an observer on a planet of a star in the Andromeda galaxy might have been able to observe it in radio waves. So they would have said, "Oh, the Milky Way is a radio galaxy," but then it switched off, and fortunately still is.
Right. Okay. There you have it, Paul. So yes, but not a very good one, I think would be the way to describe it.
Mediocre.
Thank you for your question. Mediocre, yeah. Adequate. Okay. And 50-6, Paul. Just wanted to say it one more time. Let's move on to a question from Graham, who comes to us from southeast London.
Hi guys, it's Graham from southeast London. I have a question regarding the poles and the rotation of the Earth around the Sun. When the ice caps were increasing, at some point they must have been, when the northern hemisphere was on one side of the Sun, and in the winter season more ice would have been deposited on that part of the planet. And then in 6 months later, as the planet got to the other side of its rotation, the ice would have been directly deposited more on the opposite pole and the opposite side. And if you take into account the Earth's tilt, each one of those could possibly have increased the Earth's tilt. So one side pushing in one direction and the other side pushing in the other direction. So the more ice and snow that accumulated on either pole in the winter seasons could have contributed to the tilt of the Earth. And now that the poles are melting and all the waters theoretically can travel anywhere on the Earth it wants to, but most likely it's going to level out. Do you think that the rotation of the Earth, the axis, will go back to a more...
Yeah, and that's where Graham got cut off because he only had one coin and he needed two for that particular question, unfortunately. But we got the gist of it, Graham. We got the gist of it. Ice, water, melting, freezing, tilting.
So, Andrew, it's correct that these things do have an effect on the Earth. Not so much on the tilt. The tilt of the Earth's axis is very, very stable. It does vary a little bit. And of course, it precesses around that phenomenon called precession, which is what makes spinning tops not just spin on their axis, but also they do this slow rotation as well. The Earth does that once every 26,000 years. But what it does do is change the speed of rotation of the Earth very, very slightly. I mean, we're talking microscopic amounts here, but there is a change. And you and I have spoken about this before because I think, we've often said the day is getting longer by a tiny amount. It's about 2 milliseconds per day per 100 years. And we compensate for that with leap seconds, occasionally going into our time system. So tiny amounts. That gradual slowdown of the Earth's rotation is due to the tidal interaction between the Earth and the Moon. But it's not just a uniform slowdown. And I think we spoke a few months ago about the fact that for a certain period, and I can't remember when it was, it's within the last few years, there was a period when the Earth's rotation actually speeded up slightly, only by a tiny amount, but nevertheless something that's measurable. And one of the factors that was cited for that was the possibility of melting ice. It's, the fact that the poles are changing. The polar ice caps are definitely reducing. There's some interesting physics in why climate change actually is happening more rapidly at the poles than it is elsewhere. And it's all sorts of feedback mechanisms. It's to do with jet streams and things of that sort. But the speculation was that these large-scale movements of water, and it's meltwater, is actually changing the rotation period of the Earth by minuscule amounts. But nevertheless, with our current array of atomic clocks, it's measurable. We can measure these things. So the answer is yes, it's definitely changing. It's not quite as straightforward as the question outlined, but it is happening. And the ice on the Earth's surface does change the way it rotates.
Well, I suppose to use a really rudimentary example of it, it would be like cargo shifting in a truck. It will move the truck.
Yeah, it'll move the truck.
Probably
that's right.
more dramatically than it will the Earth.
Yes, that's exactly right.
So
yeah.
That's possibly a way of describing it. It's a great question, though. Thank you, Graham. Really appreciate it. I think that brings us to the end, Fred, of another episode. I do want to actually send out an apology to Marie Claire, who messaged me the other day about the podcast and said, I hope you and Fred aren't wearing the same colours. Yeah, well, we are tonight.
Completely by accident.
Yes, and it was pure coincidence. We do not plan this. It just seems to happen. We're on the same wavelength.
Absolutely.
Because we're in a radio galaxy. I think that must be it. Also, if you do have questions for us, don't forget to upload them through our websites, spacenutspodcast.com. Click on the AMA link and you can send us an audio question, or you can send us a text question through the email interface. We take both. And if you want to do both, that's totally up to you. And just a reminder to everybody that we do have social media platforms. So we've got a Space Nuts Podcast Facebook page. We're on YouTube. We're on Twitter. We're just about everywhere. But there is a Space Nuts podcast group on Facebook, which is completely separate, and it's basically run by the listeners. So you might want to join that and have a chat to some people about what you are working on or interested in. People often pose questions to one another, and everybody has a lot of fun answering them. So, that's an option too, the Space Nuts podcast group on Facebook, which is well worth visiting. Fred, that brings us to the end of episode 256. Thank you so much, sir. Stay warm if you can, and certainly stay dry.
I'll do my best, Andrew. Thank you very much. And once again, apologies for the delay because of ice and snow at the summit of Siding Spring Mountain.
Indeed. Nice to see you again. Thank you very much. We'll catch you next week. Fred Watson, Astronomer-at-Large, part of the team here at the Space Nuts podcast, and back in mission control. Thank you again to Hugh Drury, who puts it all together with gaffer tape and duct tape and chicken wire. And he does a fabulous job of it. Actually, I did work for a radio station that was put together with chicken wire, but that's a whole different story. From me, Andrew Dunkley, thanks again for your time and for your continued support of Space Nuts, and we look forward to talking to you again on the next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.